So we have the daily concept puzzle. That's what we always start with, unless we had a test and we have nothing else to discuss. So can anyone give us the formula for, or the rule for, a constant times a function prime?
Constant times f prime.
Perfect. Can anyone give us this rule? How do we call it, first of all?
Quotient.
Yes, awesome. Can anyone help with the quotient rule?
It's f times f prime, or no, f times g prime.
Very careful, because if you say f times g prime, the number of points that I can assign is this.
Okay, my bad. So f prime times g.
Yes.
Minus.
You can say g prime times f. I don't like that. I'm not going to use it. It's perfect. It's correct. I'm not going to use it because I like 1, 2, 1, 2, 1, 2.
Okay.
But it's perfect. You don't have to switch. If you remember this one, it's fine. But I like f prime g minus f g prime. It's just a matter of habit. You create your own habit, and I'll accept it. But if you swap these two, okay, can anyone give us the product rule?
Yeah.
Anyone? Yes.
F prime times g plus f times g prime.
Perfect. A horizontal tangent to a graph of a function, of course, assuming that the function is differentiable at that point, has slope equal to. A horizontal tangent to a graph of a function has slope equal to.
0.
Excellent, thank you. L'Hopital's rule is applied only if.
Here's a limit.
Yes, awesome.
The initial limit is 0 or 0 or infinity over infinity.
Yes, so the initial value of the limit is this or this, and these are indeterminate cases. Awesome, brilliant, thank you. Tangent prime.
Secant squared of x.
Excellent. And e to the x prime.
E to the x.
Awesome. The limit of sine x plus 1 over x plus 1 when x approaches 3, is it 1 or not 1?
Not 1.
Very good. Can anyone tell us what correction would you make to make it 1?
Make the limit as x approaches 1.
Careful. So this should be
1. Should be 1.
This should be, one more time.
X plus 1.
Careful.
Infinity.
Minus 1. Negative 1.
Ah, indeed. Because x approaches negative 1 means x plus 1 approaches 0. Exactly. Exactly. So this number, if this number were negative 1, it's not. That's why we have to choose the correct answer. But if this number were negative 1, then we would have said the correct answer was 1, were 1. So remember, x plus 1 has to approach 0. You move 1 to the other side, which means x approaches negative 1. So if x approaches negative 1, sine of x plus 1 over x plus 1 will guaranteed to be this. Awesome. Excellent. Great discussion. If we don't make mistakes, we don't learn. Awesome. Thank you. Thank you to all of you who answered. Okay, so the square root of 16.
4.
Thank you very much. Awesome. Now we are ready. The floor is open to any questions you may have, anything you want to ask, anything.
Professor, could I ask a question about the WebAssign?
Yes, any question. That's why I'm kindly asking you to do the work so you can ask anything. Yes. Any question. Just
Okay,
tell us
so
which
what
section.
problem
Just tell us which section, first of all, so that students, when they get to that, they will know what to expect.
Alright, it's from 3.2. The question was, you have
Can you give us the number?
Z, number 7.
Good,
Number
awesome.
7.
So Z equals,
Z equals U to the power of 3 over 2 multiplied by U plus C and then e to the power of U.
like this,
Yeah.
with parentheses here.
Yes.
So let me
And
redictate.
it says to. Yeah, that's right. And then the question asks to differentiate and
Oh.
assume that C is a constant.
Of course. So remember, in this class, this is Calc 1, which deals only with single variable calculus. In other words, I cannot have two variables. So obviously, in this particular situation, C is a constant. So let me dictate this to you. Just watch. A U to 3/2 quantity, in parentheses, U plus C times e to U. Is this correct?
Yes.
Awesome. So we want to find the Z prime. Well, it should be correctly identified as Z prime of U. Fine. So we analyze and we decide what to apply. First of all, I want to try and see if I can simplify it in any way, shape, or form. Can I simplify it? You could say yes. I would distribute. That's okay. Let's just use the product rule because it's a product. So, can anyone start?
So would it be 3? Yeah, 3 over 2U.
Yes?
1 raised to 1/2.
Exactly. So we copy, so we bring down the power and subtract 1 from the power. 3/2 minus 1 is 1/2. But remember now I have to copy the second function. So this is my first function and this is my second function. Now I have to copy the second function, C e to U plus. Now I copy U to 3/2 and now I have to differentiate the second function. Can anyone tell us what to write in parentheses when we differentiate these two pieces? Anyone?
The U differentiates to 1.
Exactly. Plus?
I think it's the same. C.
Yes, indeed. Because C e to U prime is C e to U. Now, I don't know how they wanted the answer. You could distribute if you wanted to and see what happens. Maybe you can, but I wouldn't, in this particular case, I wouldn't do anything. But see what they want as the final answer. Do they want it simplified? Then I would distribute and see what happens. I may be able to combine like terms a little bit. I just see that because it's 3/2 U to 1/2 distributed to U. So it's 3/2 U to 3/2. And then here plus 3/2 C U to 1/2 e to U. And then we distribute U to 3/2. And then plus U to 3/2 times C in front times e to U. Yes, and I can combine these two. That's the most I can do. 3/2 plus 1, so that's 5/2. 5/2 U to 3/2, and then I have to copy these two terms. There is nothing I can do here. I can factor out, but no, not from two terms. So there's no need. 1/2 e to U plus C U to 3/2 e to U. So, Misha, what was the problem here? What do you think was difficult so we can share with everyone and with me? What was the problem? Maybe there was no problem. You just wanted to see it. That's fine too. There doesn't have to be a problem.
I think you're confusing me with someone else. I don't have
Oh, somebody else asked about this. I'm sorry. My apologies. Oops.
Yeah, it was me. I
Okay.
just wanted to
Sorry.
see it done, because it did confuse me a bit with the C, but I was kind of close, but now I understand.
Awesome. Anyone else has any other questions from anything from anywhere?
I wanted to look at, so same section, 3.2,
Yes?
and it's number 16, but it's D from number 16.
Okay, part D. Ready.
Sorry. So yeah, we are asked that if f is a differentiable function,
Differentiable.
find
Yep.
differentiable,
Yes.
find an expression for the derivative of each of the following functions. So yeah, the derivative.
So we want f prime, which is which function?
So we're given y equals 8 plus x. Sorry, so it's 8 plus, and then it's x times f of x.
Ah,
And then that's, all of that is over the square root of x. Yes.
perfect. So let me read it back to you. 8 plus x is times f of x in the numerator. And the denominator has the square root of x.
Yes.
And we want to find the derivative of this function, knowing that f of x is differentiable.
Correct.
Perfect. So let's analyze the function first. What would you do or say we should do? Any suggestions here?
I wasn't sure if, because it just the answers provided looked odd. So
Not
I wasn't
important,
sure,
it's not important. The answer doesn't, we don't care about the answer. So based on what we studied last time, can anyone recommend? Okay, based on what we discussed last time, can anyone recommend other than the quotient rule?
Do we have to find the product rule between x and f of x?
Nope, because you don't have f of x.
Could you split up?
Yes, 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 yes. So we did this last time. So we had this problem, and we simplified it. Then we had this problem, and we split it because the denominator is one term. So you have the videos from last time and the lecture notes from last time. I'm always hoping that my students will make use of it. Okay. So I will write 8 over the square root of x plus x f of x divided by the square root of x. Do you have to do this? No. But if you don't, you make it so much more difficult. So that's why please remember, simplifying and making this expression easier is always going to benefit you. Can you use the quotient rule? Go ahead. Good luck.
What's the rule called that you're getting ready to use?
Simplifying.
Just simplifying. Okay.
Yep. So then we change 8 over the square root of x to 8x to negative 1/2. X divided by the square root of x. This is the square root of x. So plus x to 1/2 f of x. By simply applying this simple algebra rule and splitting the fraction into 2 fractions, look what I have instead of that. You can say maybe for this particular one it would be easier to use the quotient rule. Yeah, maybe. But please understand that simplifying an expression before differentiating it, most of the time, maybe I shouldn't say 100%, but most of the time will benefit you. Okay, so once I rearrange the function without changing it, now I can differentiate. I'm going to call this, I don't know, z prime, so I don't have to write the whole thing again. So z prime equals, remember we bring down negative 1/2, so we have negative 4, x to negative 3/2, because we have negative 1 minus 1, which is negative 1/2 minus 1, which is negative 3/2. But here I have to use the product rule. I differentiate this first, so I have 1/2 x to negative 1/2 times f of x plus x to 1/2 times f prime. And you can,
We did end up using the product rule for this as well.
we have no choice.
Yeah.
We cannot go around that.
Yes, but you said, I'm sorry, you said like we didn't have f of x, so.
We don't have f of x.
That's when I
yeah.
saw it, this is
Yeah.
what I just.
Yeah. Yeah. Now you can factor out x to negative 3/2 if you want, and no, that's good enough. They should accept this answer. But be very careful how you enter it because, as you know, it's very fidgety.
So the answers in by the sign are all expressions, they're all written from like the quotient rule. Maybe there's like a way.
Only if you have one term. Only if you have one term in the denominator, you can do that.
He's saying it's multiple choice.
Yeah, it's multiple choice.
Oh,
The
so
only answers given are expressions based off of the quotient rule. So there's a denominator, so.
okay. So in that case, if that's what they're